This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Writing the code, it's your friend writing the code, it was correct. Your job is to tell me how old are you in terms of seconds. For you other guys, if someone asks you how many seconds are you, probably you're going to be like several hundreds of millions of seconds. Please don't answer in millions of seconds, okay? So if I ask you how old are you, don't tell me I'm 600 million seconds old. So we are giving today's date in terms of day, month, and year. Of course, those are integers, that's why we're defining them. Day, month, and year. You should give also your birthday. It's also a date. So it's birthday day, month. Okay, and birthday year. Of course, we are going to define those, to declare those integer types. You do it like this, but you can just write day, today, and erase the equal and date, okay? You don't have to do that. Yeah, erase that. Okay, still, yeah, this is it. Same for the birthday. You're doing some advanced stuff, and you're not going to know it in CS204. I suppose you're going to take CS204 course. Yeah, so you're doing something that you're supposed to do in CS204. You're not aware that you're doing it, but you're doing it. So we have 2 days from the birthday, and we're going to subtract them and use the operator minus. You are today minus birthday. But we return the days here, okay? We return the days. What if we want to return the seconds? Again, you are. If we have the days and multiply them by 24, we have how many hours are we old? If we multiply them by 60, again, we have the minutes. If we multiply them by 60, we have the seconds. So, you are this much seconds old. Did you understand this example? It's straightforward, really. Okay. So let's see how many seconds are you old. Today's, let's say, it's 23rd of November. 24th, yeah, okay. Your birthday. Yeah. So, your friend is almost 7,000 years old, and she's astonishingly 600 millions of seconds old, okay? But please don't give this number when I ask you about your birthday and how old are you. Thank you very much. You can have your seat. So this is about the date class. You're going to see more stuff like this if you take the CS204 course. Now let's go with something interesting with game programming, and namely with the robot class again, but we are going to do something much more advanced now. So let's start a new robots project. And you should know how to do it already. So this is a Windows 32 project. You can change the name if you want. We don't have time for that stuff. Okay, let's save this stuff. Go to next. It should be an empty project. This should not be checked. It's a Windows, not a console application. Finish. During this time, you can go to your folder. There is the MultiRobot demo. Just copy everything, Control A, Control Copy, and paste everything to the solution folder here. Okay? Of course, don't forget to set the character property to be not set if you don't want to have mistakes. And now add all of the existing items. So you're going to have mini FW modified, MultiRobot demo, this is the CPP, random number generator, robot modified, string utilities also, and this is it. Add them. It should take a time while we are adding. I stole a pen from you. I didn't steal it, so you shouldn't call the police, okay? I'm returning it back to you. Thank you. Okay, let's see what are we doing right now. Just see the program, because we had the robot class, and we are going to extend it, okay? Expand it. Add some more features on that class. Let me erase this board here, because we will write a lot of things. And pay attention, since your homework will have to do with the robot class, with the modified robot class. That's why pay attention to it. And I also try to be the more fast, since I have to cover the example and also trying to explain to you about the homeworks, what should you do. But first, let's run the program. So, this is the program, and there's something interesting. You are used with this GUI, graphical user interface, but check this one, don't forget about this one. File, open, and we are going to set the environment. By environment, so you are going to your folder, MultiRobot demo. There's a file which is called sample environment.rw. The extension is RW. This is robot world. So you go to File, Open, select this guy, click Open, and see what's happening. Okay, and you have this stuff. Your robots basically will be here, okay, and this is your robot. They cannot go beyond those walls. So those thick lines are called walls. Okay, how you can add a wall? You can add it by programming or by clicking. So if I want to add a wall, I click here, I add a wall. I click here, add a wall, a wall, a wall. If I want to remove it, I click them again. Okay. Now you also see numbers here. Those numbers are called things. So they are called things. If I want to add a thing, I just left click on the certain box. I want to add, let's say here, one thing. So I add it one. If I want to add another one, I click it again. This is the left click. If I want to remove manually a thing, I just right click that box and I remove it. Of course, you can put things and you can take things manually also, okay? And not manually, by programming. So you can either manually or by programming put or get things. Put or remove things. So those are called things. If you want to save this world, I mean you put things, you put walls, and you want to save your world, very simple, just go to File, Save As, and you can save your world as, you put a name, whatever, here, and save it with extension .rw, okay? This is it. Now, you saw that we included our environment with File, Open, then you select your environment. It's always with extension RW. Now let's run it. So I'm pressing run. Initially we got a message. What are we trying to do? We have two robots and we move them. One yellow, one red. This is the instruction, the manual of our game. The red robot, in order to move that, with D, we move it east, to the left. With A, okay, let's go with the yellow robot first. So right arrow of your keyboard, we'll move it to right. Left arrow, we'll move it left. Up arrow, we'll move it up. Down arrow, we'll move it down, okay? From the keyboard, just as you do it in your games. Then, if you want to put a thing in a certain box, in a certain cell, you're going to use insert. If you want to remove the thing, take a thing from a box, you're going to use delete, but this is for the yellow robot. For the red robot, if you have played Counter-Strike or any game, okay, probably you use those keys. D to move to the right, A to move to the left, W to move up. It's written north here, but it's up. And S to move south or to move down. If you want to insert a thing, you move E. If you want to insert a thing, you press E. If you want to remove a thing, you press F. And there's an interesting feature about the red robot. It's called teleportation. Namely, if you press home, what's going to happen is the following. Without moving your robot, it's going to be put in a new cell. Let's say if it's in the cell 1315, X13Y15. If you want to remove it to 00, for instance, you just press home, give the new coordinates, it automatically goes there. This is called teleportation. Okay? If you have seen science fiction movies, maybe Star Trek or whatever, there's some stuff like beam me up, and you go from your space shuttle to planet Mars or whatever. Okay? So our robots are going to be beamed up, teleported. Now, this is the initial message, and I'm playing. Initially, we have 48 things in the environment, meaning I'm just summing up those numbers, 1 plus 2 plus 2 plus 1 plus 6 plus blah, blah, blah. We have 48. The yellow robot has 0, the red robot has 0, and I'm moving the robots, but pay attention, when I hit a wall, if the robot is here, it's facing north, and I want to move north, and if I hit the wall, the robot will die, okay? Or if one robot hits another, if robots hit with each other, both of them are going to die, okay? So let's see how the game works. Okay, now, my mistake. Let's run it from scratch, because I forgot which one was which. So, let's open the environment. This is my environment. Run. Okay, for the yellow robot, I have the arrows, and for the red, I have the numbers here. Okay, so again, yellow are the arrows. Okay, initially it's like this. So I'm moving the yellow robot. When I go to this one, you see, and I want to pick this thing, I press insert, and I have one thing taken. I go here, I press insert, I took it also. You see, I have here 6 in this cell. I have 6 things. I go up, I press insert, I took 1. So the yellow robot has 3, and we have here 5 things remaining. I go take 1, I have 5. So let's move with this guy here, with the red guy. So I'm going to take one thing from here also. And this is it. So the red robot has 2, and the yellow robot has 4 things. I want to teleport the robot, let's say, to this cell here. X is 1 and Y is 0. So I'm pressing home. Now enter X and Y values to the point for the yellow robot to beam up. Okay. X is going to be 1. Y is going to be 0. And I want the guy to face west. The yellow robot to face west. That's why I'm writing west. And you see, it's teleported here. Then I'm going here, I can either hit a wall or another robot, and the robot will die. let's make both of the robots die. And you see, in the environment we have 42 things, 4 things in the yellow and 2 things in the red bag. Okay? So let's see how we are going to do this stuff. But first we are going to check the robot's modified class, the header. Now let's see what do we have inside. This is not, I mean, this is the same class that you saw, but we are going to engage in more details here. So, I'm writing the class. And you're going to do, I repeat, something similar in your homework. You're going to program a Pac-Man. That's why pay attention. The private data. What are the private data? Let's check the private. Okay, these are the private data. X position, Y position. We know what are those about, the coordinates. Direction. We know the direction also. East, west, north, south. 4 of them. The color. There were like 7 or 8 colors. We know this also. Back. Now, back, you're facing with back the first time. Back is a back. Basically, the robot, when it picks a thing, it puts the things that it has just picked in a back, okay? So this is back. Basically, back is an integer number, and it saves the number of things that it has picked, okay? So we count, we save the number of things in the back. Stalled. You see it's a Boolean value. Stalled means, is it living or not? Okay? So if you can move it, it's not stalled. Okay? If you cannot move it, it's stalled. If it has that X, okay, if it has died. So this is a Boolean value. And visible. You are not going to use this, but visible, because you might have a robot which is not visible. Okay? If it's true, it's visible, otherwise it's not visible. Name, you might put a name to your robot. I think you'll do it in your homework also. And this is it. We don't have anything else about, these are the most important part for things about the private data. Now, let's go with the public data. You already know the constructor up there, robot. I'm not going to repeat it again. Then what do we have else? Move. You know the function move. It moves to the direction it faces. There's a function which is called blocked. It returns true or false. Blocked means you cannot move it. Sometimes you go in a place in which, I mean, you have 3 walls and another robot comes on the left, let's say. You have a wall on the right side up and down, and another robot on the left, and you cannot move. This is called blocked. Probably you're not going to use it. TurnRight. You know TurnRight, what it's doing. What do you have else? PickThing. So if you want to pick a thing, you're going to use this function. It returns Boolean value, meaning if the box is empty and you're trying to take something, a thing from that empty box, you cannot do it, okay? So it returns false if you cannot do it. Otherwise, if there is at least one thing and you try to take it, you can take it, okay? So this is PickThing. PutThing, if you can put a thing in a box. So PickThing and PutThing. What else do we have? Set color. We know this guy. You set the color of the robot. Facing east, it returns true if it's facing east. Facing wall, if you have a wall in front of you, the directions you are facing, the robot is facing, you return true. If the cell is empty, this is an important one. Can you guess what it is about? SellEmpty. If you don't have anything, I mean, if you don't have a number 1, 2, 5, 6 in a certain cell, it's empty. And if it's empty, it's going to return true. BagEmtpy, if the robot hasn't taken anything with itself, the BagEmtpy will return true, okay? So initially when we started the game, so maybe it would be better if I show it to you like this. Okay, so run. Initially, so this cell is empty, but this cell here has one thing. This has 6 things. This robot is empty, okay? But now this robot has one thing. The yellow robot, 2 things, 3 things, okay? So its bag contains 3 things. And you can see the 3 here, okay? While this guy, the red robot, has 0 things. So now CellEmpty, this guy is not empty, but this cell is empty, okay? And BagEmtpy, we saw what they're doing. If the bag of the robot is empty, we say that we return true if it has 0 things inside. Now we have new functions that we have added. One of them is the teleport function. And the teleport function basically moves a certain robot without making it to move one by one from a certain position directly to another position. Teleporting, beaming. So you take X, Y, and the direction of the new position. So teleport, this is added. Okay, this is added to the class. This is teleport. What do we have else? A function turn. We have added a new function which is called turn. And what is this guy doing is the following. You take a parameter, the direction, and you immediately turn it. I mean, what we did up until now, it was if you want to turn it, if it's facing, let's say, east, if you want to turn it south, you just turn right, we use turn right. But now you can use directly turn right or turn left. And you remember the function facing east. Where's the facing east here? I mean, it was there. You can turn right the robot up until find whether it's facing east. When you know that it's facing east, then you can write the turn function. Let's say if you want to turn it to the west, you turn it right twice, okay? But you keep turning initially, you keep turning, let's say it's like this. And you're asking, is this guy facing east? No, turn right. Is this guy facing east? No, turn right. So we are sure that it's facing east. Now we want to turn it west, turn right twice. It's facing west, okay? So this is basically what the turn function is doing. But you can also, this is one of way how to do it. IsAlive tells us whether the robot is alive, meaning it can still move. Like in our case, both of them are alive, but now I'm going to hit a wall, and it's not alive, That's why we have this X. So IsAlive is now false, because the robot is not alive. What do we have else? SetRobotName. So set name. You just put the name of the robot to be blah, blah, blah. BagContent. BagContent, as you can see, returns the integer. Basically, it returns how many things we have in the bag. BagContent. So this is our extended class. Okay? The new data that we included, we had those previously. I didn't tell them about the BagEmtpy, CellEmpty, blah, blah, blah. We didn't need them, but we need them now. And we added 5 new features, 5 new functions, member functions to the class robot. But also, we are going to add some other things here. You remember those 4 functions, ShowMessage, GetInput, both of them. We added something else, GetThingCount. And those are not member functions, that's why I'm going to write them here. GetThingCount. You can use, and I think you should use this function for your homework. You give x1, y1, x2, y2. Basically, if you call this function with 0, 0 and 13, 13, you are going to, so this is 0, 0, this is the coordinate 13, 13, you are going to calculate all the things inside this big box, okay? So basically, you're going to sum out this guy, this, all of them, okay? So this is what the GetThingCount doing. You give the coordinate of the left bottom corner, x1, y1, and the right top corner, x2, y2. GetCellCount, meaning for a certain cell, I mean it takes two parameters, x and y. Let's say for this cell, I think it's 11, 13. For this cell, I want to check how many things I have. So this is GetCellCount. So GetCellCount is only for one cell. GetCellCount. We count the things in that cell. What else do we have? PutThings. You put, let's say if you want to put three things in 0, 0, you give the x and y of the cell, and you give the number of things that you want to put there, okay? If I want to put 5 things in the cell with coordinate 0, 0, and I call it with 0, 0, and 5, okay? So this was PutThings. Of course, you can put it by clicking also, but this is how you do it by coding. Number of full cells. Number of full cells meaning that cells that are, I think, not empty. It's called full cells. If there is only one thing, it's not a full cell. EmptyTheCell, I think this takes all of the things from a cell. If it says, let's say, 7 things, if you call this function, that particular cell is not going to have anything. Empty all the cells. It's going to empty all of the cells in this big box, starting from x to y, y1 as the bottom left corner, and x to y2 as the right top corner. And chase, you don't have to know this chase of this function. It's implemented, it's commented out. Okay, so this was that. This was the header file of the robots modified, meaning we added those functions, which are non-member functions. I think there are 2, 4, 6, 7 of them. And we added 5 member functions to the original robot class. And if you want to see the implementations, you can check it here, but I think it will be too hard for you, so don't check it better. So let's go with the CPP file. Okay, this is the CPP file, and let's explain it, what it is doing. Let me enlarge it. Let's talk about this function first. DisplayThingCount. Okay, this is a function inside the CPP file. Of course, don't forget to include the corresponding libraries and the string utilities, because we will need them. Let's talk about the first function. Let's explain the first function here, DisplayThingCount. This is what we do. In the end, I mean, let's run the program. Let's open the environment. So the environment is this one. It will be better. This is how I display the message. Initially, I declare one robot, 0, 0, and another one at 8, 8. So those are two, 0, 0, and this is 8, 8. Okay? The second caller, the robot is red, and this is red. Now I declare a string message, and the message is the following. Okay, so I print the message. This is the message that I print using the ShowMessage function. Okay, now DisplayThingCount. This is what DisplayThingCount is doing. When I press OK here, this is I'm calling the function DisplayThingCount. So I'm saying 40 things in environment. I sum up all of those guys. 0 things here, 0 things at the red robot, 0 things at the yellow robot. And how is this done? So, GetThingCount, you remember the GetThingCount from here? It starts from x1, y1 as the bottom left corner, goes up to x2, y2, and counts all the things, gives the sum of them. So I'm starting from 0, 0, and I'm going up to 9, 9. Basically, I'm starting from here up to here. I count all the numbers from 0, 0 to 9, 9, up to here. Then so this is the thing in the environment. Then I want to see how many bags do I have in robot 1. That's why I call the BagContent function, and it reads from the robot 1, from the yellow robot. That's why r1.BagContent, it was a member function. If you remember, you can see it in the board. I have bag 1. Then bag 2 is r2.BagContent, and afterwards I want to convert the think environment. This is integer. That's why I'm using the string utilities function. I'm converting this integer to string using itoa. Plus things in environment. This is the message, 48 things in the environment. This was returned by this function. I convert it to strings. Afterwards, I'm printing, I'm going to a new line. This is for the new line. I'm adding bag 1 for the first robot. For the time being, it has 0 things. And I'm adding itoa plus 0 things in red robot for the yellow and for the red. Plus, concatenates 2 strings. When I press OK, so I'm done with display thing count function. Then I'm going to this while function here. And this is important because this while function is going to be executed up until one of the robots is dead. Meaning that if both of the robots are alive and kicking, we are going to execute this part here. And you remember the function is alive. It returns true if the robot can move. It's alive. Meaning it didn't hit any wall or any other robot or the environment, the borders of the environment. So if the first robot is alive and the second robot is alive, we go inside and now we are doing the stuff, the programming stuff with the movement. You remember that the first robot, which was I think the yellow robot, with key right, we want to move it to the right. But in order to move it to the right, you remember the turn function? Okay, so you can directly set the direction here with this turn. So we turn it to the east and move it for 1 box, for 1 cell, okay? So if the key right is pressed, this is how you get the data that the right key is pressed. You turn it to the east, because if you want the robot to move to the right, okay, if of course it should face east, and you set the direction east and move it from 1 cell. If the left arrow is set, then the robot, the yellow robot, and in our case it's R, you should make it to, set it to face west, and then move it from 1 cell. The same applies for key up, it's north, and move it. Key down, you turn it south and move it. Now you remember the robots could pick things, and the yellow robot could pick a thing with the insert key. So when the insert key is pressed, you just call the PickThing function from the yellow robot, okay? It was a member function. So you call this one. It picks one thing, okay? If it can be picked, okay? If it cannot be picked, you can call it, but nothing will be get. If the cell is empty, you cannot pick a thing. Now if you want to put a thing, meaning the key delete is pressed for the yellow robot, you just call PutThing function, okay? And it will take a thing from its back and put it to the cell. With PickThing, it takes from the cell, puts it to its back. Well, this is for the yellow robot. Let's go with the red robot. You remember D. With D, you could move it to the west, okay? But unlike key insert, delete, and blah, 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 other keys that have characters, you can figure out that that is pressed using the character, okay? So when D is pressed, the yellow robot is going to be turned east and move. Okay? So it turns it to the left. Then, when A is pressed, have you played Counter-Strike or other gaming stuff? Or Need for Speed? Okay. So when A is pressed, you turn it west and move it. When W is pressed, you turn it north and move. Same applies for south also. But we are dealing with R2 now. Okay, this is the red robot. Of course, if you press E, E picks a thing and F puts a thing. And finally, you remember that we teleported the yellow robot from a certain position directly to another position. We beamed it up. So if key home is pressed, I mean the home button is pressed, this is what we're going to do. We declare two variables, x and y, the direction, and we print this message, enter x and y values. So this is what we are doing basically. So I'm moving the robot, and let's say that I want to beam it up to 0, 0. I press home. So this is the message again. Now enter x and y. Basically, now enter x and y. I get x and I get y. So, okay, I give x, give y, there's 0, 0. And afterwards, you should enter the direction. And it should be east, west, north, or south. Let's say I'm giving north. And it will be chosen with one of those if-else statements. And you remember the teleport function gives x and y, the coordinate of the new position, and the direction, east, west, north, or south. So if I press east, I'll get the direction here from the input, and it will be set to be east. So let's try it. Where did that guy go? Okay. Let's try it again. Run. Okay. So insert, I'm picking a thing, insert, picking, and I want to beam it up. I press home. Okay, I give 0 again, and I give, let's say, north, and I go to 0, 0, facing north. Okay, this is together with the backs, of course. And when I crash it to the wall, this yellow robot is not going to be alive anymore. Okay, so IsAlive will return false. And when the program finishes, then I print that, okay, in the environment I have 44 things. 4 things has this yellow robot, and 0 things has this guy here. I'm calling the function that display thing count. You remember it. So, end of execution. So, when I crashed it to the wall, the yellow robot IsAlive will be false. The value, this member function is going to return false. And I'm asking false is equal to true. And this statement is false, false, and even if the other one is true, this is all going to be false. So I go out from the while loop, and I again call the function displayThingCount. So I call it in the beginning here, displayThingCount, when the robot has 0 things, and I call it in the end when the robots have things picked up from the environment. Okay? So this is it. When one of the robot crashes, I again display the count in the environment and for each robot. Is this clear? How many of you did understand this one? All of you. Very nice. Now, let's play games. Do you think you can do it now? So I'm changing. So this is a famous Pac-Man. Oh, I'm sorry. I have 3 more lives. I should take all of the things from this guy. Okay. I'm playing the game since this is the game you should play. Okay. One more life, 3 lives. This is last chance. Okay, this is it. I lost. So your job will be to do something like this. Can you do it? You think yes, but actually not exactly like this, since those monsters, so this is your robot, those are called monsters. And those monsters move to chase the robot. But your task will be simpler. Those robots don't move to chase the robot, they just move, but move randomly. Okay? There's a function, if you remember the chase function here. And that chase function is, I'm going to tell you the game also. So, this is the chase function. Okay, it chases a monster. In Turkish you say hayalet, hayalet I think, huh? Yeah, chases the robot. And it's implemented here, you can check it, chase function, it's in the end I think. It's comment it out, so this is the chase function. So you don't need to do that, you can just do it to program the Pac-Man for yourself. And what you should do is the following, just let me tell you the game. Since, as you know, 20% of your grades will be the homeworks, okay? And this homework is supposed to be kind of hard, or medium. That's why pay attention to it, okay? So, what you should do about the game, let me find, okay, this is the game. This is the demo. You should open the environment first. You should be careful about this one. The environment here is robot world point RW. So you open it. This is your environment. Okay? I think you have 13 by 13. You have to put, I think, 48 things in the environment, but you put them randomly such that you don't have more than 4 things in one cell. And by saying randomly, you're going to use the random generator class. Okay? And you're going to have 4 robots, and you have your own 4 robots, which are monsters, and your own robot. Okay? So congratulations, you win. I shouldn't have won, but okay. Let me run it again. So your job will be the following. Try to avoid those monsters. And as you move, you see you are picking those things. So I go up, I take 4, and I don't have it. Your job is to go here and put 10 things. You just go there, you don't have to press anything. When you go to this box, this one, and this one, you put things, okay? As you can see, this guy is already settled, so I don't have to care about that one. So let me try. And those robots are moving randomly. You see that? They're moving randomly. Also, I have 3 lives. So let's say I'm losing 1 life. You have 2 lives left. So I continue. Let me lose another life. You have 1 life left. Oh, I don't have any more lives. But I can end of execution. But let me tell you how you are going to win. So I have 10 here, 10 here, 10 here, and you should have 10 here. I made it on purpose. You're not going to be that lucky, probably. So if I put 10 here, congratulations, you win, okay? Again, if you walk through this environment, you are going to take, by default, all the things. You're going to pick all of them, okay? And when you come here or here, at the end of your universe, at the edges of your universe, you are going to automatically put those things. And you win if you put 10 here, 10 here, 10 there, and 10 there, okay? At the top, at the edges, basically. You have 3 lives, okay? So your homework document tells you what should you implement. Please read it carefully. If you have problems, mail me. So you should implement at least those 9 member functions. Don't forget about it. Where are those? Yeah. At least you should implement those 9, okay? Also, so when a monster robot dies, and how does a robot, any robot, monster or your robot, when you hit another robot, when you hit a thing or a wall, you die. But when so monsters move randomly, okay? When they hit each other, they might hit each other, they might hit the wall, they should automatically resurrect, okay? Become alive again. They don't have 3 lives, they have infinite number of lives. But your robot has only 3 lives, okay? So this is it. Any questions? Yeah, just imagine, this is your 2nd week, and you are able to program games, like Pac-Man. Probably you didn't expect this, huh? So at the end of the semester, you are going to program Counter-Strike or maybe Need for Speed. I'm joking. Okay. See you guys, this is all. Have a nice weekend. See you next week.